early on in the life cycle of a project. The final set of activities we call solution evolution. This involves all the changes that are made after the solution is deployed. Typically, a problem that software is supposed to solve, and I think Kurt also referred to this, the problem doesn't stay fixed. The problem will change. And sometimes having software available to solve a problem will make users realize that that was only part of what they needed. So having software that solves partially the problem that was originally defined will make users now see potential for all sorts of improvements, enhancements, new features. And I'm not talking here about fixing defects, fixing bugs. I'm talking about adding new functionality. Because that's really what happens with most software systems. They grow over time. They grow and they change over the many years that people use them. One direction of growth is moving to other platforms, other operating systems, other hardware, or moving perhaps from a desktop environment to being a distributed system. Other kinds of software evolution involve functional changes, functional enhancements, hopefully making the software better and more useful to the people who wanted it in the first place. Now, when people talk about these as phases, there's generally this notion that, well, first you define the problem, then you design the solution, then you implement the solution, then you test the solution to make sure that, in fact, your implementation is correct, then you release it, and then you start making additional changes. You start evolving it. That is it's overly simplistic. That's not the way things work in the real world. And this terminology that we use, this activity terminology, is not standard because we want to get people away from the more traditional terminology, which implies this kind of linear flow through time. Now, most software engineering books, if you read them, they will say, well, this isn't really the way it works. So it's not like we're giving you revealed wisdom that other people haven't recognized. But by using a different terminology, we hope to sort of get you away from thinking of this as a linear sequence in time. So what kind of temporal complexities might we have? Well, here I have my activities, and I've got them lined up as if they're in time, right? So I don't think there's any possibility of not starting with defining the problem. Because if you don't know what you're trying to accomplish, you have nothing to go on in doing your design. And as Kurt pointed out, software engineering really is not that useful if you can't define your problem, if it's an ill-defined problem. So you start from problem definition, and once you've got a statement of what the problem is, what the requirements are, you can start doing a design. One thing that happens in the real world, though, is that the process of doing the design helps you to see things about the problem that you missed the first time around. So you'll be working on the design, and all of a sudden there'll be a question. When I say you, I mean the software developer, the person who's doing the design work. You'll come up with a question, and the original problem definition is silent on that question, doesn't give you an answer one way or the other. So what that means is that you have to go back and refine the problem definition. And then once you have refined the problem definition, you've filled in this gap that you've discovered, you move on and you can continue working on the design. And this can happen many times, this kind of cycle. It's not just a one-time thing. The general process of repeating activities like this is called iteration. Or you sometimes hear this that this is an iterative process. You may know the word iteration from programming. When you're talking about a do loop, you talk about iterating through the do loop. Well, here it's the same general idea. We have a loop here where we're moving from problem definition to solution design. The solution design points out gaps in our problem definition. We come back, loop back, and so on. Now, hopefully this is not an endless loop because you'll never build the system. And it usually isn't. What you find is that the process of iterating helps make the design richer and the problem definition richer in terms of more information, more detail, more precision. So that when you finally go into the solution implementation, you know more about what you're trying to build than you would have if it had looked like this and you hadn't had that looping back. So this is one way in which it's not linear. Another way in which it's not linear is that even as you're starting to write your code, you can also be doing validation in parallel. So it would be nice to have these two next to each other so that you could see kind of a branching, but I didn't want to do anything fancy with graphics programs or anything like that. So you can be working on coding some parts of the design, and you can be at the same time validating the design itself, and we'll talk about some techniques for doing that, and also validating the code that you're implementing. Okay. The other thing that can happen in an iterative environment particularly is that when you design your solution, you decide that you're not going to deploy it all at once. You're going to build a smaller system that has limited functionality, deploy that, then build more and deploy that. So you end up going from validation to deployment and then back up to implementation. This is pretty much of a straight line. By definition, evolution doesn't start until after you've deployed a particular iteration, a particular chunk of functionality. But what is involved in solution evolution? Well, it's really starting the whole design process over again. So the first step in evolving a package to the next stage is saying, all right, we now know we want more functionality or different functionality. We need to define that functionality. So we're back at problem definition. So this is really not a set of phases in time. It's a set of interactions between different activities. And as a software engineer, you need to, first of all, know which of these activities you're involved in. And second of all, be comfortable with the notion of going back and redoing some work. You'd like to think, oh, I did that design already. I don't really want to go back and change my UML diagrams to match the new design. It's too much work. But it's necessary, or at least it's part of the software engineering process to be doing this kind of iteration and this kind of looping back. You shouldn't expect it to flow linearly, because it's only in textbooks and in old textbooks that's what the software process looks like. So I said that we had sort of coined these new terms to get away from the traditional implication that these are phases. But the textbook uses the more traditional terminology. And so what I've done here is mapped our terminology to the terminology that's used in the industry generally. Problem definition is frequently called requirements analysis or requirements specification or simply specification. In all cases, it's a question of deciding and recording what the software has to do, what is the problem the software is trying to solve. design is typically called